So we've all seen Earth's auroras at places like Norway or Iceland. They usually appear at the poles, but what if I told you we have now captured Neptune's auroras too? So for the first time ever, NASA's James Webb Space Telescope has captured Neptune's auroras, but as we have seen in Earth's case, they weren't at the poles. Given Neptune's magnetic field is so tilted and off-center, the auroras appeared at the equator instead of the poles. And these cyan flashes were made up of rare molecules called trihydrogen cations and were invisible due to being in the infrared frequency. This discovery is not about auroras but also about magnetic mysteries, space weather, and atmosphere of exoplanets. So, welcome to my video. This is 5 scientific discoveries you missed in 2025, part 1.
Game start!
So, what are auroras? Auroras are beautiful glowing patterns of light which appear on the skies of planets. They happen when charged particles from the sun, which is called a solar wind, slam into the planet's magnetic field and atmosphere, exciting atoms and molecules, making them glow. So, on Earth, this creates aurora borealis, which is the northern lights, and aurora australis, which is the southern lights. So these lights can be of 4 colors: green, pink, purple, and red. And on other planets, such as in the case of Neptune, these auroras can look wildly different and tell us a lot about the planet's magnetic field, atmosphere, and space weather. So, until now, Neptune's auroras have been elusive and mysterious, barely visible in ultraviolet, weak, and irregular. But in 2023, NASA James Webb Space Telescope has changed everything. And in March 2025, the world has for the first time seen a clear infrared image of Neptune's auroras. So, what has the telescope found? It has found a cyan glowing patches at mid latitudes, not near the poles like it was in Earth's case. It has also found strong emission of trihydrogen ion, a unique marker for auroral activity, and a surprising drop in upper atmospheric temperature, which is by hundreds of degrees cooler than it was last recorded in 1989. So, the key facts about this aurora is that the location occur near Neptune's magnetic poles, but these poles are oddly located due to the tilted magnetic field, so that's why the auroras appear at the equator rather than the poles we would have expected. Then the magnetic field is tilted by 47 degrees from its rotation axis and significantly offset from the planet's center. The type of the auroras is considered as auroral emissions, but unlike Earth's auroras, they are not bright and dancing lights. Neptune's are dim and hard to detect. And the cause of this is the interaction of solar wind with Neptune's magnetosphere and ionosphere. And the color of these lights have been observed in ultraviolet range, not visible to the naked eye or in normal optical wavelengths. So why would this be considered a big deal and why this is so important? So it completes the aurora puzzle with Neptune's confirmed auroras. All giant planets in the solar system now have verified auroras. It also unlocks magnetic field insights, so the non-polar mid-latitude auroras provide clues about Neptune's complex asymmetrical magnetic field. It also shows that it is not really compulsory for the auroras to appear at the poles and can appear at mid-latitude ranges. It reveals about atmospheric evolution. So, dramatic cooling of ionosphere suggests that Neptune's atmosphere is dynamic, even far from the sun. So, what will be happening next? So, James Webb Space Telescope will have ongoing observation for over a solar cycle, 25 solar cycle, which is approximately of 11 years, to help track any changes. There will also be improved models. The temperature shift and mid-latitude auroras will redefine the models of Neptune's magnetosphere and ionosphere interactions. And it will also support missions. Insights from James Webb Space Telescope will guide the design of future Uranus and Neptune missions, emphasizing on infrared sensors. This has solved a 36-year-old mystery. So Neptune's auroras were first hinted during a flyby in 1989, but we never clearly saw them. So with James Webb Space Telescope finally confirmed that they are actually not in ultraviolet range but rather in infrared range, showing how faint and unique they are. Given auroras appear due to the solar wind interaction with the atmosphere of the planet, Neptune is a cold, windy ice giant 30 times farther from the sun than Earth, but yet auroras still exist. Understanding them helps us explore similar planets in other solar systems and even identify which could support life. So this is just one thing you have missed in 2025 and want to know the other four. Please hit the subscribe button and like this video, and stay tuned for part 2, which is coming really soon. And this is the end of this video, and bye.